Let's try to understand how to apply power of function rule. So in general, if a function is given in the form of another function to the power, so that becomes a power function, then its derivative is n times the function to the power of n minus 1 times the derivative of inside function, right? So this is what power of function rule is, and we'll explore it more with the help of these 4 examples. So it says determine derivative f dash x of the following functions. Now these are different kind of functions. So we have a polynomial, a quadratic square root function, and reciprocal combined with a radical function, right? So once we do that, so that will give us a good range of practice. Now the very first one is a power function, and here as you see 2x is also a function in itself, right? So f dash x is equal to, so if we apply the power rule, it becomes 3 times pi times 2x to the power of 3 minus 1, which is 2, right? Times the derivative of inside function. So what is the derivative of 2x? It is 2. So times 2. That is what is power of function rule. So what we get here is, we get, when you open the bracket, 2 gets multiplied with 3, so you get 6 pi, and this when you square, you get 4x squared, right? And this could be written as equal to, so we can write this as 4 times 6, 24 pi, and x squared. So that is how it gets simplified. So remember, this is how you have to do it. Now you can check your answer here. If you do first open this bracket, right? So what do you get here? You get f dash x, fx as cube of this is 8, right? So you get 8 pi x cube plus 1, right? Now derivative of 1 is constant, which is 0, right? Therefore it was 0 here also, so we just didn't write anything. So f dash x will be 3 times 8, 24, pi is a constant, x squared, right? You see same result, correct? So derivative of 1 is 0, so we are not writing anything, correct? So that is how the power of function rule works. Now this was an easy case, we could expand it and do it. But if we have something like 1 minus 2x to the power of 3, for that matter to the power of 5, then it will be difficult, right, to expand always the function inside. And therefore this rule becomes very handy. So let's apply this rule now to part B. So what do we get? We get f dash x equals to, well, derivative of this constant is 0, so I'll not be writing anything there, but derivative of this first part is 5 times 3 is 15, 1 minus 2x to the power of 3 minus 1, which is 2, right? Times derivative of this. Now what is the derivative of this? 1 minus 2x derivative is minus 2. So we'll multiply this by minus 2, and this derivative of minus 1 is 0, so we get this. So when we open this up, you can write this as minus 30, 1 minus 2x whole square, right? So that is the answer for the second one. Now let's apply power of function rule here to part C. So we get f dash x equals to, this is 3x minus 5 to the power of half, right? So it comes like half, 3x minus 5 to the power of 1 minus half, rather I should say half minus 1, because it's to the power of half, minus 1, times derivative of inside function, which is 3x minus 1. Derivative is 3 times 3, correct? So for this we get 3 is in the numerator, 2, and this is half minus 1 is minus half, so we get square root of 3x minus 5 as our answer, correct? So that is the answer for that one. Now here it is better to write it as negative exponent, right? Then we will apply the rule. So fx can be written as 2 times 2x minus 3 to the power of minus 2 over 3, correct? Now from here, what is f dash x? F dash x will be 2 times minus 2 over 3, correct? Times inside function, which is 2x minus 3 to the power of minus 2 over 3 minus 1, times derivative of inside function, which is 2 times 2. Do you see that? So that is what you get as derivative of the given function using power of function rule. So this can be simplified, and you can write this as equals to, so 2 times 2 is 4, minus 2 gives me minus 8, right? So you get minus 8 over 3, and here we have minus 2 minus 3 as minus 5 over 3, right? So at present, let me write like this, 2x minus 3 to the power of minus 5 over 3, and then I can always write this as minus 8 over 3 times. Now this comes in the denominator, right? Cube root of 2x minus 3, and this is to the power of 5, correct? Okay. Or you could have written as 5 over 3 as given in the question. Anyway, so the idea here is to explore how to use power of function rule. So the rule is apply the power rule and multiply by the derivative of the function itself, right? So it is basically power rule times the derivative of function itself, that is g dash x, right? That is how it is. I hope you understand. Thank you.